Hello, and we will be starting the homework video for chapter 7. We'll do 7.1 and 7.2 in this video, which is all about confidence intervals and how to deal with those things. Okay, so a magazine provided results from a poll of 2,000 adults, blah, 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 blah. Okay, so among those who were 2,000, 14 chose chocolate pie. That's a percentage from a sample, so that's the sample proportion. I thought they were going to ask what that is. So the sample proportion is the proportion of, or the percentage of successes from the sample. Okay, Q hat is going to be 1 minus that. So if you want to find Q hat, do 1 minus is 14, so it would be 86%. N is the sample size, that should be 2,000. E is the margin of error. In this case, they want the margin of error was given as plus or minus 3 points. And P is the truth. That's the population proportion, which is the truth. It's a good question. Okay, the confidence level was 90% was the alpha. We did this in the video. So essentially the way this works is alpha is whatever's outside of the middle. So the way confidence intervals works, the confidence level goes in the middle like this. So these two together are your alpha. So the way to do this is just 0.10. Now the question says to put in an integer or a decimal, so don't put a percent right there. Okay, same question. The margin of error was given as plus 4 points. So let me kind of draw this thing out. So what's going to happen is we're going to put the 14% right here. That's this guy. Now, the 90% confidence interval is going to give us an upper. It's going to give us a lower. And the margin of error is going to go from here all the way to here. So they put that at 4%. So 0.04, or you could think of it as 4%. Okay. It's definitely not the first one. I'm looking for something in the question that says something like the truth. We're hoping the true P falls somewhere in here. We want P to fall somewhere inside these two ranges. So I'm looking somewhere to say that the sample result of 0.14 is about 4%, should be about 4% from the truth. Okay, it's definitely not the third one. Okay, it's not the last one. So basically what they're saying is if you take your interval, this lower right here would be 14 minus 4, so that'd be 0.10 would be your lower, and your upper would be the 14 plus the 4, which is 18. And what they say is the true proportion is likely to fall in here if the margin of error is 4%. So that's what that means. Okay, so here, express the confidence interval. Here's the confidence interval. So if you looked at the video, I had a equal sign in there, which it could be equal. All we have to do is put these numbers in there. I mean, it's that easy. It's just another way to write intervals. We don't necessarily need the 0 past that 5. Okay, now we did a bunch of these. Let me draw this out. Okay, so my interval is 81% from here to here. What that means is that there's 100 minus 81% on these outsides. Now remember, I'm trying to find this guy right here. I'm trying to find this z alpha divided by 2. I'm trying to find that shade right there. So 100 minus 81 is should be 19%. So then this side's going to be 0.19 divided by 2. Okay, so that should be 0.095. You could run your calculator. The way I did it was 9 plus 9 is 18. So I needed to get to the 19, so I just add the 0.5 right there. Okay, so I'm looking for z 0.095, which is found under the normal calculator. So I have StatCrunch back here. If you watch the videos, you'll see how to do this. So we want to go to normal calculator. Sorry, it's going to be kind of hidden there. Put it down here. This side over here needs to be this 0.095. Needs to go down here. And this has to be a greater than sign. Okay, because we're working on the right side. So 1.31, I'll go ahead and, I'm going ahead and paste in that. Oh, what question are we on? Oh, they gave me a different one. Ugh. Oh, we did all that hard work. Okay, so let me see, 2 decimals. Okay, so if you do 90, if you do that whole process, you should get 1.65. So, made me lose it. Let me just keep a little bit over here so I could grab it. So you're going to go right into that normal curve that we just did. The 81's way harder, 90's way easier. If this is 90, then this is 5%. So in that little box on your normal thing, you want 0.05. And you should get this number right here. '90 is a pretty common one. That's why I knew it. Like I didn't know the 81 because 81 is not something that we do a lot. Okay. Let's get some more practice at these. My middle's 82. That leaves my outside to be 18. Both of these together are 18, but I don't want both of them. I just want this side, the right side. That should be 9%. I'm just going to put that over there because I don't want to lose it. So now I just have to come over here. See how I have 9% there and a greater than sign. Two decimals, 1.34. Okay, there you go. Okay, so I'm going to go ahead and put the important stuff. There was 540 babies and 970 were girls. And we did a 99%. Okay, so anything that has to do with counts is going to be a prop stat. So we want to go stat, prop stat, One sample and summary. Data would be like girl, boy, girl, girl, boy, 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 stuff like that. Successes, there was 297. Observations was 540. Get off this thing. Go to confidence, we want 99. And compute. Okay, 3 decimals. Now what I'm doing is I'm putting in this lower. Oh, I didn't want that to happen. I did not want that to disappear. Okay, let me not mess with it. Yikes. I apologize. I'm trying to make the screen smaller so you don't have to painfully do it. Okay, here we go. 0.495. And the other one, 0.605. Okay, so that's how you do your interval. Okay, now to be effective, it would have to be basically 50-50 means it's like half-half. There's like no benefit. Okay? The lower to this, since 50 is in here, we could pretty much say that it doesn't seem to be effective. Now if this lower was like 50 something, then you say you could. Okay? Okay, there's a little tip there. Okay. Okay, so let's go ahead and run this. So we want to construct a 95% confidence, the percentage of yellow. So we're interested in yellow. So how many yellows were there? 152. Well, how many P's were there? There wasn't 431. It was 431 plus the 152. Okay, so I'm just going to do that since I don't have a calculator right next to me. I think this would be just easier than do it there. So that's your N. Okay, and we want 95. I'll pay attention to that. Now we can find the interval. Remember, anything with a proportion is always a prop stat. I'm always going to go through the motions. I'm not going to take shortcuts. Stat. Proportion stat. One sample. Summary. Number of successes, 152. Number of observations is how many P's we studied all together, 583, if I did adding right. And we want to be 0.95 and compute. I'm not going to mess with this too much because I don't want that thing to disappear. But the lower end for the yellow is 0.225. And the upper is 0.296. I just got these from here, lower and upper. The reason why I didn't cut and paste, as soon as I hit this little guy, your homework disappears. Okay, now, it was expected that 25% of the P's would be yellow. So all we have to do is 25% inside here. If you go from here to here, are you crossing 25%? If it crosses 25%, you can't doubt that. You can't doubt their 25% because 25 is in there. So if somebody says that it's 25 and 25 is in there, it could easily be that. Doesn't mean it's going to be that, but it could be that. Okay. Okay, so go ahead and pause this and read this question, okay? The first question says, what proportion of correct would you expect if the therapist made random guesses? Well, if it's right or left hand and they're making random guesses, that would be 0.5. That's just, basic statistics. Okay, the point estimate would be how successful. What was the fraction of times that the therapist was successful? So it did it 130. Sorry, she was correct 131 times out of 277. So this is your point estimate, which we call p hat. Okay, now in this case, I'm going to need my calculator. So I need 131 divided by, okay, and we need to go to 3 decimals, 0.473. Man, she doesn't seem too successful. Okay, so now we need to construct an interval. Now, it's sometimes a trick to doing an interval is to hit options and then edit, and it just takes you right back to the screen, and then just change your numbers. So this is how many times the therapist was correct, and she tried out of 277. Just gonna double check on my percentage, my confidence level. 90%. So I change this level to 90% and compute. Okay, so we have 0.4, let me see, 3 decimals, so 0.42, in case you're not sure, I'm looking right here, right here. Okay, so 0.424. Just rounding to 3 decimals, and the other one's 0.522. Okay, now for her to be successful, she has to be, both of these numbers would have to be above 50%. See, since the confidence level is not entirely above 0.5, that's going to be it right there. For her to be successful, her worst case scenario is right here. She was below in the sample, so she'd have to be a lot better than the sample for us to say that she's successful. Okay, this is a finding a sample size problem. So what we need here, we're trying to find this n. That'll give us a margin of error, .55. We want to be our confidence level is 0.99. That's our confidence level. Okay, and there's no prior p hat or p. So our target is set at 0.5. Okay, so let's go do this problem. I did these problems on the worksheet on the earlier video, so you could check this out, or I could show you how to do it here. Okay, so what you want to do is go to Stat, one prop again. Or sorry, prop stats, one sample. But don't go to here, go down to width. See width and sample size. Confidence levels here, 99. Since we didn't know any p-hats, we got 0.5, that's set there. The tricky part's this width. So if you remember on the video, the margin of error is always half your interval size. So they have to go from here to your upper at 0.055. So the width is double that. There's another 0.055. So that's 5.5% plus 5.5%, which is 11%, which is the same thing as 0.11. So if you add that plus that, you should get this. Or if you do this times 2, you should get this. And then when you hit enter, it's going to tell you, oh, there's a decimal in there. I'm going to put a 0 there. Okay, so once you hit enter, it's going to tell you the sample size that will guarantee you these results. So 549. Okay, hopefully everything went good there. Okay, so assume the prior survey suggests that 33%. So everything's going to be the same except the target. We're going to get a new target of 0.33. This n is going to go down because 50% gives us, when you set your target at 50, it gives us the biggest possible sample size. I need to flip this back too. See, it went down to 485. So if we were to know from prior that's 0.33 with the same old results, our sample size doesn't have to be quite as big. Oh. Sorry guys. I forgot. I think it's 485. 485, there it is. I'm getting there. Make sure you guys are decent at those. It's going to be another one of these. Make it straight now. Actually, I don't need that page. This page I need. Okay. Government financial aid. They want to estimate full-time students. Blah blah blah. Find the sample size. That's the clue right there. Find the sample size. This is find the sample size. We're trying to find n. We don't know. Okay, so right here, margin of error, 0.05. So our width is going to be 0.10. We want our CL level to be 0.99. Now I'm looking to see, do we know anything from like some previous something from before? And as I scan through that, there's no previous, so our target, which our worst case, is going to be set at 0.5. Now we just go back to this thing right here. Same 0.99, nothing previous, 0.5. Margin of error is 0.10, and I did it again, didn't I? 664. No, okay, there we go. So we need 644. Okay, let's see what I did wrong. Seemed like I had everything right. Margin of error is confidence level 0.99. Maybe I put it in wrong. 644. That's what I did. It's not 664, it's 644. Sorry, it's 664. So I just put it in wrong. Okay, good. Okay, so if we assume that the prior was 40%, our target's going to change. Once our target changes, we don't have to pick as many as we had picked before. And the margin of error was 5%, which sets our width at 10%. Should be less than 664, 637. Okay, so watch that pack a few times if you need it. Let's work on this side. How about that? Okay, it didn't look like it only slightly reduced it to me. So I would say A. It only slightly went from 664 to 637. Didn't drastically change it. Okay, so this is the same type of problem. So I'm going to let you guys watch the other video and do that one. Just to save some time. It's the same thing. I'll just kind of write it up, but I won't do it. The CL level should be 0.9. He wants his estimate to be within 8 percentage points. So your your width needs to be 0.16. It's double the 8 percentage points. And there's nothing prior, so your target needs to be 0.9. Sorry, 0.5. See? Okay. Those guys. Alright, let's move on to 7.2. Okay, so they give you the interval. There's no need to run it. They gave you a t interval. So all I have to do is put these numbers in here and put them there. And 2 decimals, so I need to go 0.5. They're trying to trick me. Now for problems that estimate mu, the intervals aren't going to be in decimals for the most part. Okay, to find the point estimate, the point estimate sits the number that's right dead in the middle of your interval. So right now, they gave us the lower at 13.046. They gave us an upper at 22.15. The point estimate lands right here, which is your x bar. So what we have to do is take the average of these two numbers. That's it. So what we need to do is we need to do 13.046. I used the original. Plus 22.15. So adding them together, you get this, and I have to divide that by 2. So I have 17.6. 17.60. Should be right. Okay, to get the margin of error is the distance from here to here. So what we're going to do is we're going to find the distance from here to here by just finding the range, doing 22.15 minus 13.046. That'll tell me how long that is. Whatever that is, we're going to divide it by 2, which will give me the distance from here to here, which is your margin of error. Okay, so 22.15 minus 13.046. So this whole thing's 9 long. Divide that by 2. So the margin of error is 4.55.